Good evening, everyone. Please confirm me if my voice is audible. You can confirm in the chat box. Okay, right, fine. Thank you for the confirmations. And also, please confirm me if my screen is visible. Uh, Please confirm my screen too. Yes, thank you. Thank you for your confirmation. Okay, right. So let us start our programming part. Okay, in the last session, I introduced a module, one more module, which is nothing but Node MCU. Okay, uh, so there are some updates. Let me skip that. Okay, right, fine. So I introduced a module yesterday, Node MCU, which is ESP32, and we are trying to do some hardware sessions using this particular ESP32 because we can also use some simulator, so like VOC and Proteus, etc., etc. So for the practical knowledge, so I just I'm using this hardware session real modules so that. You can also see how it is working and all the stuff. Okay, I hope these classes are interesting. So if you missed anything, you can go back to our previous sessions and you can go through all those things. Okay, so in today's session, so we'll try to work on few more things. Okay, let's work on that. So okay, right. So in let's work on ultrasonic sensor. So we already know about this particular sensor. We saw this particular sensor in our what we say Tinkercad. Okay, am I right? So here let's work on this particular ultrasonic sensor. Okay, so this is an ultrasonic sensor. Generally, okay. Mm, for your understanding, okay, right. This is good. So this is an ultrasonic sensor. We just saw this particular sensor. Let me save it for an understanding. Right. So this is an ultrasonic sensor. Okay, we have a transmitter and a receiver with four terminals are there. So one is VCC and trigger pin, echo pin, and ground. Okay, trigger pin is used to transmit the signal, and echo pin is used to receive the signal. So to this, sound waves will be traveled. Okay, and we'll receive that particular sound waves through the receiver. Okay, so once we receive, we got the duration, and the duration we try to convert that into distance. Okay, so we have a formula like distance equal to duration into sorry, sound means speed. So with that particular formula, we are going to extract that particular, I mean, we are going to calculate the distance of that particular object. Okay. So let's work on that. I hope you aware of this particular programming part. So we already did. So we'll try to cover that particular programming now. Okay. So can anyone guide me in this particular thing? So we already did, right? So can anyone guide me? So let me open this. So what is our first step? So before going to write any code on this, we need to have a pin layout. Yes or no? Using that particular pin layout, we need to check to which pins we are going to connect. So I already downloaded that. So let me open that. So this is a pin layout. Uh, why it is open in this? All right. So this is a pin layout diagram. Okay. So looking to this, we are going to write the coding part. Guys, if you have any queries, you can ask in the chat box for your understanding. So first of all, to this particular ultrasonic sensor, we need have a trigger pin and echo pin. So let me connect that. So let me define ash define. So okay, you can also define this in another manner also, because we are using this uh, regularly. So let me use like constant int. Okay, that is also one more way to define that. So trigger pin. So let me connect that to which pin shall we connect? Okay, let's go for 25 and 26. Okay, so trigger pin is connected to 26, and also constant int echo pin, so which is connected to 25. Okay, got it, guys? Right? I hope it's clear for you. Okay, and here I'm going to store some values. Okay, uh, so for that, let me use like so ash define. So I'm storing the sound speed. Okay, so I'm storing it. So it is 0.034. We already know that. So it is in say suppose it is in centimeter per microsecond. Okay, yes or no? So let us convert that into inches. So ash define like sorry, cm centimeters to inch. Okay. So for that, we need to multiply that with 0.393701. Okay. So that is, we need to convert. Okay. So that centimeters, if you multiply with this particular number, then we'll get distance in inches. So I'm just storing all those stuff. And also let me store like duration. Okay, one. And also let me take a float for distance in centimeters and distance in inches. Okay, I'm taking two variables. Okay, one is for centimeter, another one is for inches. That same program. So I'm writing it in little different manner. So rest of the things are the same. Okay. So let me use a serial monitor to read that particular distance and the duration. Okay, right after that we need to define like pin mode. So pin mode, so trigger pin. So let me connect trigger pin is output, yes or no? And echo pin, right? So echo pin, which is an input. Okay, am I right? So trigger pin is nothing but it is a transmitting signal pin, so which transmit the signal, and then echo pin is used to receive that particular signal. Okay, so first of all here, initially I need to transmit um, a signal, right? So trigger pin comma high. Okay, and I'm transmitting it for some 10 microseconds, so that I'm using a function called delay in microseconds of 10. Okay, so after that, digital write of same trigger pin comma, I'm making it low. Understood, guys? Right? And after that, what I need to do is, so as we are doing this in hardware, we don't know whether the initial stage of this particular trigger pin is in high or low. Okay. So to avoid that particular confusion, what I'm doing is Initially, let me make this particular trigger pin as low. Okay. So I'm giving a delay of in microseconds for 2 microseconds. That's it. Okay. So because I don't know whether my trigger pin is in high state or low state, to avoid all those particular confusion, what I'm doing is I'm making my trigger pin as low for 2 microseconds and then making trigger pin as high and transmitting it for 10 microseconds and then I'm making it as a low. Okay. So after that, we all know. So duration is equal to, okay. So we are using a function called pulse in function. So through echo pin, I'm going to receive that particular signal. So we already saw this in our previous things. So first of all, so distance in centimeters, which is equal to, so duration, right? Duration into, so we already defined that particular sound speed, right? Which is nothing but 0.034. So let me use that sound underscore speed. Okay, this the variable I declared that. Am I right? So sound underscore speed. Okay, and I need to make it by 2 because the signal will be transmitted twice. So transmitted signal and receiver reflected signal. So that signal is transmitting, traveling for 2 times. So I'm making it as 2. Okay, I hope you know all this. Let me convert that into inches. So um, distance of inches is equal to distance in centimeters into that centimeter underscore. We already declared that. What is that variable? Like 2 inches, right? So 2 underscore inch. Okay. So I got the distance in both centimeters as well as in inches. Okay. So let me print that. So serial dot print of, okay. So distance in centimeters. Okay. And serial dot print ln of what is the distance of cm. Okay, which is nothing but centimeter. I'm just displaying this particular centimeter. Okay, right. And after that, serial dot print. Okay, so here I'm writing like distance in inches. Okay, here for that, let me display like serial dot print ln. So distance inch. So this is what the variable we took. So let me give a delay like 2000. Okay, just for our uh, convenient purpose. Okay, got it, guys. Very simple program, nothing much. So the same program which we discussed in Tinkercad, the same stuff I used here. So so what we need to do? We forgot to select the board. That is not a mistake. Okay, it's not man thing. So first of all, we need to select the board. So select, click on the select the board. So before compiling, so first of all, yesterday's in the previous session I told you, right, first of all you need to select the board and the COM port before writing the code. But if you forgot like me, that is not a sin. Okay, so after writing the code you can select that particular board. Okay, and select the port. Okay, so but before writing the code, selecting the board and the port is a good option, good habit. Okay, so please habitate for that. So select the board and then click on verify. So you can see if there are any errors, then you can see that particular error. Syntax errors will be displayed. So done compiling, you can see, and also keep an eye on this particular what we say, uh, program space. Okay, right, fine. So let me connect my, I have an Arduino, sorry, ultrasonic sensor and a board with me. So give me some time to connect that. So as you all know, ultrasonic sensor have four terminals. So VCC, ground, and echo pin and trigger pin. Am I right? So I'm connecting wires to that to connect to my ESP32. Okay, right. So here, if you carefully observe here, so in this we have 3.3 volts. Okay, so we need to give power to 3.3. So VCC to 3.3. Yes, I connected. So beside that particular pin, we have a ground. So I connected ultrasonic ground pin to ESP ground pin. Done. And after that, so here we are using 25 and 26. Am I right? So 25 pin is used for echo. So just we need to connect that. So echo pin is 25. So echo pin is red one. And the trigger pin is connected to 26, right? So I just connected the VCC ground and thing. So let me go back to the serial monitor. Just click on this particular serial monitor. So we need to upload, right? Sorry. So just upload it. We forgot to upload. Okay. So before uploading, it also checks again. So it is uploading. In some cases, guys, try to remember. So in some cases, you'll see an error while uploading the code because you connected your sensors or some components to that particular board. So this uploading the code will show you an error. So if in that particular cases for few modules, you just need to detach all your connections and then upload. Then you'll get that. So just click on that particular serial monitor. So we need to select what you can see over here 9000. So right, my sensor is not connected properly. Just a second. So 25 is sorry. Just a second. 25 is echo pin. Echo is orange. I connected in a reverse direction. 25 echo. Right. Okay, right. So in the serial monitor, now you can see, let me remove that. So you can see here, the data distance in centimeters is 275 because this is, I'm not keeping any of object or anything in front of that particular ultrasonic. So this is the maximum thing. So let me keep an object in front of that. Now you can see. So the distance between that particular object to the sensor is 7 centimeters and 2 inches. Okay. So you can see like that we can vary. Okay, now you can see the centimeters is in 2.3 and 0. Okay, so there are some movement is there. Okay, like that you can detect that particular things. Okay, understood, guys. So this is how you can display your how you can use your ultrasonic sensor for different applications. Is there any queries in this particular program, guys? Very simple program, nothing much complicated. Understood? You can reply in the chat box, right? So this is how we are going to calculate the distance using this particular sensor, which is nothing but ultrasonic sensor. Okay, got it. So if you have any queries in this, you can ask me, guys. Okay. Right. Right. Just disconnected. Fine. So let me write one more program. So I have one more sensor with me. Okay. Which is nothing but soil moisture sensor. So let me write that. So I'm opening a new one, new sketch. Right. So here I have a soil moisture. Let me show you the soil moisture sensor, how it looks. Right. Sorry, soil moisture sensor. Okay. So this is a soil moisture sensor which are available in our um, market. Okay. If you carefully observe over here, so this is an electrodes where we need to dip this in our soil to know the moisture content. And here, okay, let me show you this in a big. Right. So this is a soil moisture sensor. This particular sensor will comes with what we say a module and then electrodes. So this is the sensor where we need to keep this particular sensor in the soil. Sorry, this electrodes in the soil. There are two electrodes are available. So we need to connect this particular or insert this particular electrodes into the soil. Okay, to know the soil moisture content. Okay, and to this particular soil moisture, this electrode, so we have an module is available. On this particular module, you have a potentiometer and a comparator is available, which is nothing but LM393 comparator. And we have our terminals are available. So terminals are nothing but so VCC, ground, D out, and A out. Okay. So to this particular sensor, we can collect analog values as well as digital values. Got it? So A naught and D naught is available. So if you want like digital data, whether it is moisture is there or not, okay, at that particular time you can check like you can connect D naught. And if you want to know what are the values of that particular ultrasonic sensor, then you need to connect to analog. So analog values will give you that particular data. Okay, got it. So we'll try to explore both what we say a analog and a digital. Okay. So let me work on that. Okay, so come back to our IDE. So here, let me open. So here, let me use some other modules. Anything is fine, guys. Okay. So right, let me go for. Can anyone suggest it? Like say suppose 34 or 35. Okay, anything is fine. Okay, so first of all let's work on digital. Okay, so as defined. Okay, what is the soil, right? Soil D man, it is nothing but digital. Let me connect it to 34 pin. Okay, right. And go to that setup and we need to initialize that. So pin mode soil D, which is nothing but it is a sensor. So definitely we need to enter input. And we need this particular serial monitor. So I'm writing this statement like 9600 as serial dot begin thing. Okay, and so let me write that serial dot print ln. Okay, so let me write like so checking just for the soil moisture content. Okay, I'm just want to display that. Okay, nothing else. Uh, okay, so I'm coming back to the loop. Okay, very simple thing. So let me write like serial dot print of soil moisture in digital format. Okay. So then serial dot print ln, and what we need to do. So sorry, not that. Digital read of soil T. Okay. So the values will be printed. So I'm just giving a delay of 2000. Okay, Vajin bar delay of 2 seconds. Okay. Understood, guys? Any queries in this? Okay. So I'm just initializing that and displaying that using digital read. Okay. So, right. And after that, what we need to do, we need to check whether my board is connected. So, Node 32S and COM port both are connected, right? Fine. Then verify the code for any errors. Okay. Right. No errors are there. Let me upload the code. Compilation done and uploading is in the progress. So code is uploaded. Okay. And let me show you where we can use this. Here I saw an image. Right. So this is the image. You can see, right? The same thing which we are doing. So this electrode will be dipped in this particular soil of any plant, and then we are writing this particular. So they used a breadboard. Okay, that's not an issue. Okay, right. So this is how we can check it. So some people may connect an OLED is also there. Sorry, OLCD or OLED. Yes, OLED. So to get that particular information, okay. So is that available here? Okay, let me write LED. All right. So this is how they used. Anything is fine, guys. Right. So OLED will be there, like soil moisture content. You can display like this also. Okay. So the OLED, the soil moisture. Instead, we saw that LCD, right? So in what we say, uh, that moisture content, which is we can print that particular things over here in this particular OLED. So this OLED looks like this. You can also print like this over soil constant. Okay, you can print in this particular format. So this works with I2C protocol. So we already seen that, right? Okay, so this soil moisture things will be available in two different things. This is a capacitive soil moisture sensor. You can see that what we are using is a passive inductive soil moisture sensor. Okay, so we what the sensor, this sensor, okay, this sensor which we are using, this is an inductive type of sensor, and this is a capacitive type of sensor is also available. So you can choose any one thing. So in generally most of the cases we use this type of sensors only. Got it, guys? Okay, let me come back. Okay, someone is asking, what if electrode get corrode? I didn't get you. What do you mean? What is that corrode? Okay. So right, data is uploaded. So let me connect it. Okay. So fine. First of all, A naught, sorry, VCC and ground. So VCC. So in the similar fashion, how we connected this thing. Okay, right. So then you need it won't work properly because these sensors which we are using in our general project point of view doesn't have that big things. So in general, if you want to use in a real time applications, so let me show you the actual what we say soil moisture. sensor. So it comes with some, let me show you. Okay, this is one type of sensor is available for that particular soil moisture. A part of that, we have some one more sensor is available. This type of sensor, right. So this sensors will be available in the market. Okay, right. This is also one of the other soil moisture sensor. From that, we can extract the data. Okay, so in real time scenarios, you can use that. So you can see here. So these are the sensors are available. So where you can use it in your fields. Okay, just for the program point of view, we are using this. So these are the sensor moisture sensors which are available. Okay, this sensor will just you detect you, okay, that not accurately, but almost it will use like 60 to 70% you can use. These are the soil moisture things which are available in the market. So you can use all those stuff. This is also one more soil moisture sensor. Okay, so you if you are using in a real time situation scenarios, you need to use this type of things, not the one which we are discussing. Okay, right. So what I'm doing, okay, let me connect it, right? So uploaded, done. So so let me connect it. So VCC first, let me connect VCC, and then ground. Okay, so we wrote for digital, right? So let me connect to digital. So which pin? 34. So 34th pin is connected. Fine, right? So let us see the output. So this is a serial monitor. So here, right, you can see soil moisture in digital format. It is 0. So here I have a small pot with me. Okay, dry soil and wet soil both are there. Let me show you. Now you can see here. I inserted in wet soil, so you can see the output is 0. So as we are working on digital platform, so we'll get only zeros and ones. Okay. So now let me remove that from that soil. You can see one. You are getting one. So one in the sense nothing but you are having a dry soil. Okay. So I inserted back to this thing. Then you can see it is an wet soil. Okay. Right. So that is how you can use it. So let us explore the digital format also, sorry, analog format at all. Let's see what are the values it will get. Okay. So for that, ash define. So soil A is nothing but analog. So let me connect to 35. Okay. And also we need to define that. So pin mode soil A, which is nothing but analog. So is an input. Got it? Right. And here, so let me go for one more stuff, run more for analog serial train of print, uh, soil moisture in analog format. Okay, and serial dot print ln of what we need to write. So analog read of what is that, soil A. Okay, if we want to read, we need to use that analog read, right? So the same stuff. Okay, so let me compile the code. Okay, let me compile it. So okay, and there are no errors. Okay, so 20% of program space is used. Upload the code. So the code is uploaded. Okay. So let me connect it. So we are using digital pin format also, right? So digital, sorry, analog format that I connected it to 35. So right, connected. Okay. So let me go for that serial monitor. Okay, you can see. So it is giving some values, some analog values. What are these analog values, guys? So I told you that this is having an inbuilt ADC, analog to digital converter, that will converting and giving that particular values. So let me insert that into a wet moisture. So you can see these are the values. So 0, and you are getting some values. Okay, like 15. Okay, that is a minimum. Okay, if I inserted a normal one, then the values will be increased. For a digital platform, you can't expect what we say some variations. You can see I slightly imported the moisture content of the soil is little bit less. Okay, then if I completely dip, you can see the values are changed. Okay. So if the soil moisture is light, the values will be changing. If there is no soil moisture, you can see some values. Okay, got it, guys. Somewhere you will get up to full maximums. There is some soil on my electrodes. Okay, now you can see the values like 38,000. Okay, it means that there is no water content. Yeah, you can see, right. Okay, like that we can, according to our applications, you can develop all this. So just now I showed you, right? So, right, in this soil you can connect and you can check in this particular format. And the same thing you can display it in your, what we say, OLED also, the moisture content you can display it. Okay, so that is what, okay, let me disconnect it. So this is about the soil moisture sensor, which we can use it in our agriculture projects. Okay. And let me introduce you one more module or sensor, which we generally use in our applications. So, which is nothing but DHT sensor. Okay. We call that as a DHT sensor. Let me show you that particular sensor. Right. So here we have that DHT sensor. Okay, so this is the DHT sensor, which we generally use this particular sensor for temperature and humidity. Okay, so this DHT is nothing but digital temperature and humidity sensor. Got it, guys? So we generally use it for any, if you want to know the temperature of your room or something like that. Or in the outside environment, if you want to know, uh, we use this particular DHT sensor, which is nothing but we'll get that humidity and what we say, humidity and temperature values. Okay, using that. Okay, which is nothing but digital humidity and temperature. So that is what DHT means. But this particular DHT will be available in two modes. One is DHT11 and DHT22. So these are the two sensors which you see on the screen. Okay, so blue color one is nothing but DHT11 and the white color one is DHT22. So both are the same, but the range is little bit different. So almost both will have the same features. You can see here, data and everything. So here this is the sensor. So one, two, three, totally four terminals are available. So VCC, data, no connection and ground. Okay, but this particular sensor is mounted on a chip. then you'll get this particular type of chips in the market. Okay, this type of chips. Okay, this four terminal will be connected, mounted on this particular chip, and for this particular chip we'll have only three terminals. Okay, one is VCC, ground, and data pin. Okay, VCC, ground, and data pin. Okay, or a signal pin, anything is there. Okay, so let us work on this particular thing. So let me open a new sketch for you. Okay, right. So here, to use this particular sensor, guys, any queries till now? If you have any queries, you can ask in the chat box. Are you clear? Understanding what I am saying? You can reply in the chat box. Okay, right, Sen. Right then. So let me write this. So for this, what we need to do is we need to include a library. This particular sensor is provided by Adobe Fruit company. Okay. So for that, they introduced a library, which is nothing but DHT.h. Okay. So how to include? We all know Ash include DHT.h. Okay. So this is the library we need to include. Okay. For this particular library is not pre-installed. Okay, so there are some libraries are there. Whenever you install this particular IDE or install the package, some libraries will be installed. Okay, and also there are some versions are also there, so we need to include that particular library manually. So for that, what we need to do is to your sidebar, to your left side, you can see the library manager, the third one. Okay, so the library manager will be opened. So in that particular library manager, you need to search for DHT. Okay, search for DHT. There are multiple libraries are available for this particular DHT. Just you need to search for Adafruit. Okay, right. So this is there are two Adafruit DHT KXN, and there is a DHT sensor library by Adafruit. So we need to install this particular library. Okay, so there are different versions are available. So this particular IDE will update you that particular libraries. If you see in the initial things, there are some updates. They push some updates like there are new libraries updates are available. Like that, new versions will be updated automatically. So first of all, you can see an install button will be enabled over here. Just you need to click on that particular install option. Then this library will be installed in this particular IDE. So that is the first step which we need to do. Okay. And the second one here is, so here we don't require any pin mode type of things. Okay. For that, we are having a class and we need to create an object. Okay. So DHT, okay, let me write that particular syntax for your understanding. So DHT username. So that is what we need to uh, write the pin. These are the arguments and which type of DHT sensor you are using. Type TYP. Okay, so this is the syntax for that. So let me write. So DHT is the class. Okay, and we need to write a username. Okay, let me write the same one which is in small letters for our understanding. Okay, and pin, to which pin we need to connect this. Okay, let me go for whatever pin any is fine. So say go for 17. Okay, any pin is guys, right? So 17 comma, and here with me I have a DHT11 sensor. So this is DHT11. I have this blue one. Okay, so we need to write DHT11 need to use. Okay, so as we are using this library, we need to use this particular statement. So DHT and the username, this is a user defined name. So DHT, I use the same DHT, and to which pin I connected this particular DHT sensor. So I connected to 17th. I mentioned that, and what type of DHT sensor I'm using. So I'm using DHT 11 sensor. So I use that. Okay. To display that particular value, so I'm using my serial monitor. So begin 9600. Okay. And this is to enable my serial monitor. And in the same way, we need to enable my DHT sensor also. So for that, we need to use DHT dot begin. So we need to use this particular function or this what we call method, instance method or something. So we need to call this particular to enable my DHT begin. Okay. So let me go back to the loop. Okay. So here, let me take some float value. But as you all know, DHT sensor is used to read temperature and humidity values. Am I right? So to store the humidity value, I'm taking HUM to store the humidity. So how to read? You may have a doubt. So we have only one signal pin. Okay. So through one signal pin, how can we read the two different parameters like temperature or humidity? Okay. So for that, we have a method which is nothing but read humidity. So whenever we use this particular read humidity, then the humidity value will be read. Okay. In the similar way, taking one nothing but temp. So similarly, so using that particular object, DHT dot read temperature. Whenever we use this particular method, then the temperature values will be displayed. Understood, guys? That will be stored in this particular temp. Okay. Very simple thing. Only two statements we need to required. And then let me print that. So see dot print humidity. Okay. Serial dot print ln. So to store that, so I am taking humidity values and so serial dot print of. So let me use for temperature. Okay. And serial dot println of temp. Okay. I'm just giving some delay of 2000. Understood? A very simple program, nothing much complicated. Just we need to include the library and we need to create an object. And we are using digital humidity to read the humidity values and read temperature to read the temperature values. Okay, done. So after that, just check whether your board is connected properly or not. So 32 and COM port is connected. Okay, click on OK. Okay, and connect it. Okay, so just compile it. Compile it. So done, and I'm click on upload. Click on upload. Right. Fine. So they uploaded successfully. So someone is asking to show the connections. Okay, no worries. I'll show you the connections. And also DHT stands for digital humidity and temperature sensor. Digital humidity and temperature. Okay. So just a second. Let me turn the video on. Just give me 1 second. For every sensor, there won't be any header file, but for few sensors, we have this particular what we say libraries. Okay, so we need to use that particular libraries. Okay, okay, just a second. So just we uploaded. So let me. Nothing much complicated connections. Very simple. So let me connect first, and then I'll show you. Okay, VCC and ground and ground pin. Okay, once it got uploaded, so it is uploaded. So let me connect it. Give me 1 minute, guys. So red is VCC, is VCC, and white is ground, and so to which pin we connected? Forgot 17, 17, 17. Okay, where is 17? Beside 16. Okay, right, fine. Okay, and let me open the serial monitor. Some NAND values are coming. Just me, let me check. Orange is display. Yes. Yeah. So you can see some values are coming. Okay. So let me show you the connections. Okay. Just a second. Right. Spotlight for everyone. So I hope you can see my video. Okay. Right. So this is my connections, guys. Right. So this is a sensor. Okay. Which I have. Okay, just a second. Let me. Okay, fine. So this is my sensor. You can see this is a sensor and this is a module which I'm using. Just I connected it. So this particular sensor having three pins, right? So VCC, ground, and data pins. So I connected to my uh, 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 sensor. Okay. So with that particular sensor, I mean the data will be transmitted. So these are backside we have the particular pins, so we can connect to that particular pins, and then you'll get them data. So as this is a temperature and everything will be common, right? So that's why you get the same values. So whenever you placed it in some other locations, then the values will be changed. Okay. So this is one more important sensor for some point of view. So nans are nothing but not a number. Okay, try to remember this. Not a number, NaN. Okay. So there are some loose connection to my sensor. So that's why it is giving some nans. So whenever you see nan, nothing but the sensor is not connected properly. That is the only indication for that particular nan. Got it, guys? Clear with till now? Any queries? Any queries, guys? If you have any queries, you can ask me. So you can ask me in the chat box. Is it clear? Okay, right, fine. So let me check for some other. I'm just checking my modules which are available based on that. So we have LDR is also there. Okay, just like the same stuff which we discussed. Okay, that the same thing. And with me, I have servo motor is available. Let's check this particular servo motor. Okay, a very simple program, same program. Okay, we all know the servo motor. We already did. I just want to show you the real practical part. Okay, so how a servo motor looks. Servo motor. Right. So this is a servo motor which will get for our point of, I mean, our project point of view. There is a blue color one which is for 9 volts. Okay. And there is one more black is also there which works for 12 volts. Okay. And you'll get like this. Okay. What we say with some connections, wires. Okay. You'll get like this with other peripherals. So not this one. Okay, with some gears, I mean not gears, some white color ones. Okay, and this is how you'll get the same color wise for you also. So let's write this particular code. Okay, let me go for a new sketch. Okay, okay, fine. So we already know. So can anyone tell me what is the program? We already discussed this, right? Okay, we already discussed it. Can anyone guide me through the code? So you can push in the chat box. Please guys tell me how we can write. Okay, fine. So first of all, we need to include a library. Yes. So which is nothing but servo.h. Okay. So this particular library. So first of all, we need to go to the servo and we need to check for that particular library. I hope this is a predefined library. There no need to install any library, I guess. Uh, yes, right. So, right, the servo for this particular thing is ESP32 servo. Okay. And we need to install this library, which is nothing but ESP32 servo by Kevin Harrington. So, we need to install this particular library, guys. Okay. There is an update is available. Okay. It is asking for an update. For right now, it is not mandatory. Okay, so you need to install this ESP32 Servo by Kevin Harrington. Okay, we need to install this. Okay, so the header file name is nothing but ESP32 Servo. Okay, for someone asked like, is this mandatory for every sensor? Okay, only for few sensors. So that's what I'm introducing those sensors. Okay, so after that, what we need to do, guys? We need to create an object, right? So servo is a class and I need to create an object called my servo. Okay, got it. And we need to attach. So to which pin shall we connect? 19th. Okay, anything is fine, guys. Okay, so my servo dot attach. I'm connecting it to 19th. Okay, so let me define over here for not confuse to avoid confusion like servo pin. So let me connect it to 19. So attach servo pin. Okay. And we need to enable, no need to enable servo monitor, not needed. So let me write over here directly like my servo dot right. We already discussed this. Okay. We need servo motor is nothing but which turns with some angles. Am I right? Right. So my servo dot right of 45 and a delay of 1000 and my servo dot right of say suppose 90 and a delay of 1000. Okay, got it, guys. So this is a normal how to rotate this particular servo motor, and I'm just introducing all the what we say inputs and outputs individually. And in your project point of view, you can combine these particular codes and you can work. Okay. So first of all, let me check whether it is connected or not. See, check whether the board is connected. So click on that. The board is connected. You can check here, Node 32 and comment right then. So verify and then upload. Okay. Directly will I'm clicking on upload because um, before uploading the program, it will compile, right? So to avoid double compilation, so compiling process, I just clicked on directly upload. Okay. Okay, got it, guys. So it is uploaded successfully. So let me connect it to my board. Okay. So let me see the connections. Okay. So this is the connections. You can see brown color, red color, and orange color. So brown is for the negative supply, negative in the sense ground over here. Okay. So let me connect to ground. this is a clear image. Brown is for the negative supply, which is nothing but the ground, and red is nothing but the positive. So, okay, fine. So, orange is nothing but the signal pin. Okay, so that we need to connect it to which pin I connected. So 19. So go to the pin now diagram. 19 is available. So let me connect it to 19. Okay, let me show you the output. Let me turn my video on. Right. So this is my servo. Okay, you can see over here. 4590. 0, 4590. 0, 4590. 0, 4590. 0, 45, 90. Like that, it will be. We wrote it in loop. So every time if you turn on, then you will be that same things will be displayed. Got it, guys? Understood? So that is about the servo motor. Okay, so you can use it in different applications like turning a gate on, rotate on. So whatever the applications, you can work on this particular servo motor. Is it clear, guys? Any queries? Any queries? If you have any queries, you can ask in the chat box. Thank you. I hope you are understanding what I am saying. The hardware connection, the programming. Yes. Right. Thank you. Thank you. Just give me 1 minute of break. Okay, right, guys. So let us work on a feature which is available in this particular uh, ESP32. So there are two main features are available when compared with Arduino thing. So one thing is Wi-Fi. So we'll see that Wi-Fi a little later. And they have one more feature which is nothing but Bluetooth. So this particular ESP32 will have these two features are available. One is the Bluetooth and Wi-Fi. So first let's work on this particular Bluetooth, and then we'll work on what we say Wi-Fi. Okay. So in today's session, we'll try to complete this Wi-Fi, sorry, Bluetooth. We'll work on that, and in the next sessions, we'll discuss about Wi-Fi. Okay, how to connect to a Wi-Fi, how to send the data. That we'll try to discuss. Okay. So now we'll try to work on Bluetooth. Okay, let me open a new file. Right. So are you with me, guys? Right. Fine. So let us work on this particular Bluetooth. Okay. So here, so for this particular, to enable this particular Bluetooth, again, we need to have a uh, header file. So we need to use that particular header file, which is nothing but ash include Bluetooth serial dot h. We need to include this particular Bluetooth serial. So to enable our serial monitor. Okay, right. So here, this is an inbuilt library. No need to install it again. Okay. Whenever you install this package, this particular library will install. Okay. And then uh, what we do, so we need to create an object. Okay. So just like how we are creating for serial servo motor, similarly, so Bluetooth serial. So this is a class and we need to create an object. So I'm creating an object like serial BT. BT is nothing but it is an object. Serial BT is an object from that particular class. Okay, got it. So here coming back to the setup. So here I want to enable my serial monitor. So I'm using little more baud rate here. It is not mandatory that you need to use for just for an testing to aware you. So I'm using that particular baud rate, which is nothing but 115200. So this is an baud rate. Okay. And then, so we need to connect Bluetooth, right, to this particular Bluetooth. Okay. So for that, what we do is we need to give a name to this particular Bluetooth. Okay. So to our module, we need to give a name. Okay. So let me give a name like, okay, for that. So serial DT dot begin, just like how we did for the DHT sensor. In the same way, we need to begin. We have a method called begin. Okay. So here we need to give a name. So let me give a name like say suppose ESP32 underscore. Let me give my name like Pranay. Okay. So this is nothing but, so for an understanding. So this is nothing but the Bluetooth name. Okay, so we are going to connect to this particular name. Okay, got it, guys. So here, whenever Bluetooth means we need to send some data. Okay, so why we need this particular Bluetooth? Why we are using this? Okay, so the connectivity we are going to establish the connectivity. Say suppose if you want to turn an fan or a light on using the Bluetooth, so we need to enable this Bluetooth, right? So there are two types of communications are there: wide connection or wireless connection. Okay, so I'll discuss wide connection little later. Okay, but here we are going to control a device using a Bluetooth. Okay. So for that, we need to connect to that particular Bluetooth. Say, suppose if you are using a headphones, Bluetooth headphones, what do you do? So that particular headphones have a name, has a name. Am I right? So whenever you turn your Bluetooth on, whenever you turn that particular device on, so you'll search for that particular name. Similarly, so to this particular ESP32, I'm defining a name. Okay. So that name is nothing but blue ESP32 underscore pranay. Okay. So and after that, so after connecting it, so let me display like serial dot println. Okay, if it is successfully connected. So what we need to, so Bluetooth is ready. So I'm just displaying it. So send uh some messages. Okay, just a normal messages. Okay, right? Understood? Okay, I'm just want to send some messages. So here in the previous program, okay, while whenever we discussing uh what we say, see in serial monitor, if you carefully observe, there is an input panel is there. Okay, right? So we did this in our Tinkercad. Okay, right? So this is the input where we can text, we can write some text like text or whatever. If we write the text and keep on enter, the data will be sent, right? So in for that particular application, what we did is we used a statement called serial dot available. Okay, right? So here we need to use this particular object and we need to check whether it is available or not. Okay. So if it is available, okay, if any data is available, so what we need to do? So we need to read that particular data using a method called read. Okay. So after reading, we need to store it, right? So let me store it within a string format. So string says suppose received data. Okay, got it. And then let me print that particular data. So serial dot print. Okay, like received data. Okay, and serial dot println received data and giving some delay of 1000. Okay, got it, guys. I'm just want to check whether the data is transferring or not. Okay, so that is what I want to check. Okay, so this is how you can enable your Bluetooth in your module. Okay, so let me upload it directly. So before uploading, the compiling will be done. Okay. There is an error. Where? Available spelling wrong. Okay. Available. Sorry. Okay. There is some error. Why? Into to string. Okay. Let me. Okay, right. There is some error in the string. I'll check it. So here, one main issue with this particular Bluetooth is Whenever you use this particular Bluetooth module, your program space will be filled. You can see here the 82% of program space is filled. Okay, so it means that whenever you are using Bluetooth, you need to use only for a smaller applications. Okay, so if you go for a larger ones, okay, then the program space is not sufficient. Just you can. That's what I'm to conveying you from the beginning. So right, you need to check, keep an eye on this particular program space. Okay, so right. Fine. So now output it is up. Okay, let me click on upload. Okay, now okay, you can see the data is uploading. Okay, so let me first of all, so we need to have an application in our mobile phone. Am I right? So as we do have an Bluetooth in our mobile phone, so for that we need to install a mobile app, general mobile app. So Bluetooth serial. Okay, so terminal. There is a mobile app application is available in our Play Store, which is nothing but Bluetooth serial Bluetooth terminal. Okay, so you can use this particular Bluetooth serial. So let me use this. Just a second. I'm trying to install this. Okay. Uh, right. This is one platform. There are multiple Bluetooths are there. So if you are from CSE background, if you know how to develop a mobile application, then you can use this you can develop it using Bluetooth. So first of all, what you need to do is, so open your Bluetooth settings. Okay. Open your Bluetooth settings and first connect to this particular board. Okay. So just search for this particular Bluetooth. Okay. So the same name will be displayed. Okay. So Bluetooth ASP32 underscore Pranay. I'm connecting to that. It is pairing. Okay. Pairing done. Okay. Now after that, you need to go to that particular app which you downloaded. Okay. Okay. Just let me check. Okay. Right. So you need to first of all, you can like this, you need to connect to that particular image. After connecting, go to that particular settings. Okay, and then go to devices. Okay, how I need to show you this? Okay, okay, just a second. Right. So here, first of all, after first step is right thing, but you need to connect this particular device in your from your Bluetooth menu. After that, open this app and go for this particular options and select devices and select that particular ESP3240. Once you connected, then you can see the device got connected in that particular image. Okay, so let me go back over here. So serial. So let me write something. Okay, so here we need to set the baud rate. So how we need to set the baud rate? So here to your left side, you can see it is a 9600. Okay, right? So here select that the baud rate which we wrote in our programming part. Okay, and then you can see here Bluetooth is ready and it is sending some messages. So let me send some message so here we connected what we checked like we mentioned character, right? So let me send a message like A. So you can see over here A is received. Okay, so let me type like P. So P got received. Understood. So I sent a string format. So say suppose I sent like Pranay. Now you can see over here in this particular. So the Pranay will be is splitted into character and each character is displayed. Okay. So let me check one more time. So let me type like XLR. Okay. So let me type XLR. Then you can receive C. XLR. So each format it will be displayed. Got it, guys? Clear? Like that, you can explore. Based on this received data, you can store it in a string format later on, and you can, what we say, do some operations. Okay. Say, suppose, let me modify it little bit. Okay. Like, let me comment it. Okay. So here, let me write something. Okay. Like if received data is equal to say suppose yeah. Okay, so what I need to do, let me write like serial dot println like uh, hi hi students. Okay, some message. Okay, else if. Okay, if received data is let's say suppose p. Okay, so what I need to display like serial dot println like welcome to XLR. Okay, just a normal thing. So if A and P, I just define. Okay, uh, verify it for any errors. Receive data. What received spelling is wrong. Receive data. Right. There is some error. Why? Okay. And dimensions. Single quote. Okay. Here it is received data. Very simple, guys. Nothing much complicated. You can also do on your own. Okay. Uploading the code is uploading. Okay. Okay, done uploading. So open my serial monitor and check it. So it is ready. So my Bluetooth is connected. So let me send A. So you can see hi students. I'm sending a message like A. So let me send P. So if I send message, you can see welcome to XLR. Okay, right. So right. So again, just like that. So you can receive hi students like P, welcome to XLR. Like that, you can do all the stuff. Whenever you receive that particular stuff, then you can work in different aspects. Got it, guys? This is how you can do your programs with using what we say Bluetooth. Okay, understood. Any queries, guys? Any queries? Any queries? You can push in the chat box. If you have any queries, you can ask me in the chat box. Sir, can we connect it any device? What it means, sir? We connect it any device? Can we connect any device like another phone? Another phone. So you, from phone only you are going to connect it. Yeah, you can write the code in VS Code, but you need to save the file with .ino extension. Okay, so don't forget, you need to save it in .ino format. Okay, you can follow some steps. You can use that. Okay, right, fine then. So let me discuss one more small topic, and then we'll wind this up. Okay, so let me control a electrical device. Okay, either fan or a bulb using the same process using Bluetooth. Okay, I just want to work on this. Okay, so for this particular thing, we need to have one more component called relay. Okay, so this is a relay module which we need to connect to an electrical appliance. So here my task over here is using the same Bluetooth. Okay, I want to turn a bulb or a fan on. Okay, electrical. So in between, so electrical items or the fan or a bulb, whatever it is, an AC component. But our module is a DC component. Okay, so using that particular, how we can what we say control an AC appliances or electrical appliances using this particular Bluetooth or a DC component. So for that, with between this AC component and a DC component, with this electrical like a fan or a bulb, and with between this bulb and this ESP32, we need to integrate this particular what we say relay module. So this relay module will help you to configure that. So one end you need to connect what we say AC wiring, and to the other end we need to connect to our ESP port. Okay, so let me show you the connections how it connect. Okay, yeah, this is a good way, or this is a good way. Okay, this is a two terminal. Okay, let me go far. This is a one terminal. Okay, so this is how you. This is also a two terminal. All right, this is fine. Okay, instead of this particular Arduino, you can go for ESP32 module. Okay, okay, let me type ESP32. Yes, yeah, this is fine. Okay, right, fine. So you can see over here. Okay, right, fine. I'm just searching for that particular diagram. Right. So to this particular ESP module, so you need to connect like this. First, take a cable, two terminal cable. So in generally, we connect a bulb or a thing in this particular way. So, but to a relay, what you have to do is inside this particular two the wire, we are having a two wires. So cut one end, okay, which is a positive one, not the negative, positive, and connect it to normally open and common. Okay, normally open and common. Okay, so what happens is, so inside this particular terminal, so you'll be having a switch will be there. Whenever this just like your LED, whenever you pass high voltage high from the Arduino pin, so this switch inside this particular relay will be activated, and these both pins will be shorted. So whenever these both wires will shorted, this bulb will be on. Okay, so that is the programming, I mean, the working condition of this particular relay. Okay, got it. So to the other end, you need to connect that where you can see over here. Okay, so here wire will be there. If you connect a common, so you need to cut this wires, and one wire is need to connect to common, and the normally open. So here the 5 volts you need to give power supply 5 volts and ground to the other end. And if it is zero, your bulb will be not is in off condition. If you pass some high voltage like pin, so the bulb will be on. Okay, so this is a hardware connection of that. I already connected this. So let me use the same Bluetooth program. Okay, and connect over here. I'll write a program over here. Okay, so let us initialize that. So let me write over here like as define bulb. So let me take a bulb, and I let me connect it to some module. Which pin? So let me go for two. Okay, two. Okay. So here we need to mention like so pin mode. So bulb, which is an output. Okay, got it. Rest everything is the same over here. So here, right. So see data. So here we need to mention, right? Right. So let me write delete and write over here. Okay. So instead of hi students, let me write bulb is on, and we need to write a digital write of bulb comma high. Whenever a is received, say suppose let me go for say suppose one. Okay. So similarly, uh, let me write over here like bulb is off. Okay, let me pass a 0 over here. Okay, so this, sorry, digital write off bulb comma low. Okay, so whenever I pass 0, bulb will be off. Whenever I pass 1, bulb will be on. Okay, so that's it. Okay, this is how we need to do it. So let me upload the code. Okay, but whenever you are doing this, you need to be little bit careful while you are connecting your relay, because we are dealing with how much 230 volts. If something happens, you'll get short. Okay, I'm not scaring you. I'm just giving a caution. Okay, so because you need to be careful, something happens, you'll be in trouble. So I already have the connections with me. The relay is already available. Okay, right? So let me give some connections. Okay. So VCC, I'm connecting in this way, guys. Okay, already I'm connecting these 5 volts and ground from to my ESP module. So this is VCC. VCC, let me go for 3.3. And this is ground, ground. So to which pin we connected this? Oh, where is this? Sorry, I forgot. Right. So to which pin we connected? Two. Okay, right. Fine. Right. Open the serial monitor. Okay, and check. Bluetooth is ready. So I'm opening my same app which we used till now. So connected. So let me send one. So bulb is on. Okay, let me open the send 0. Bulb is off. Okay, right. So okay, right. Let me show you. Just a second. I'm connecting. Okay, right. Uh, okay, right. Just a second, guys. I wrote it in reverse condition. So, right. Say, let me go for 0 and it is 1. Okay, the relay is working in reverse. So, let me upload it one more time. And I'll show you this output also. Don't worry. So, it's compiling and it is connecting. So, here, just a second. So this is the error because I already connected my relay board. So that's why you are giving this. This is what I told you before. Okay. So before uploading, just you need to remove that particular components and then you need to upload the data. You need to be little careful while you are connecting this relay module. Okay, because we are working with 230 volts. I'm not scaring you. I'm just giving you caution. Okay, it is uploaded successfully. So let me connect it to VCC, right, and second pin. Okay, fine. Right. So, okay, fine. So let me open the serial monitor. Okay, fine. Is off 0. Just a second. Why it is not? Just now it is on, right. Just a second, guys. Yes, it is on. Off. Okay, I need to be little careful. Uh, so just a second. Okay, right. There is a loose connection. Just a second. Yep. Right. Yeah, this is my bulb. Okay, let me turn it on and off. Just a second. I hope you can see this. It is in on condition. Let me go for off. Hmm. Yes, now you can see off. Okay, right. Similarly, I'm passing 0. Turn it on. So there is a loose connection. Now it is on. Okay. Similarly, sending 1. Okay. So we need to receive that. 1 send. Is not of 50. On, let me send 1. 1. Hmm. So device is not responding. Just a second. No worries, guys. So let me. Oh, let me re-upload the code once. What happened? Device an error. Okay, let me check it one more time. Changing baud rate. Why? Just a second. My device got some error. Nothing else. That is a simple thing. Nothing much complicated. And don't worry about it. Code uploaded. So let me connect it one more time. Black BCC, white ground, and this is D2. Okay, fine. Just a second. It is showing some error. Just give me 1 second, guys. Okay, device on my connected. Okay, fine. So let me show you, try to show you the same part. Okay, Faria. Shake. Yep. So let me turn it on. So it is on, right? And let me turn it off. Yes, it is off. So bulb is on and sending 0. Fine, fine. The like that you can control and electrical appliances using this particular Bluetooth module. Right. So that's it. If you have any queries, you can ask me, guys. Any queries in this? So this is function features. So which we can control our electrical appliances. Okay. So very simple thing, but just you need to be careful whenever you are using this 230 volts. That's it. Okay, if you have any queries, you can ask me, guys. So that's it for today. And the next session, we'll try to discuss some Wi-Fi using Wi-Fi, how we are going to control. So now it's time for queries. Thank you for your feedback. Okay. If there is no what do you say queries, so we'll wind up our session.